All right, guys, I'm going to run through this fairly quickly, and hopefully it will make sense to you. So first off, an object is blank if its position relative to a fixed point is blank. It is moving if its position relative to a fixed point is changing. A person is driving in a circle at 20 meters per second. Are they accelerating? If they're going in a circle, then they are accelerating because they're changing their direction. So yes, they are accelerating. In a free fall problem, when told an object is dropped, if it is dropped, we're given two things. We know its initial velocity is 0, and we know it is accelerating under the influence of gravity. So that is this one right here, acceleration of gravity, initial speed. If an object is said to have traveled 45 meters east, that is a vector. I have direction and magnitude, so that is my displacement. It is said to be traveling at 80 meters per second. That is a scalar. That is speed. An object falls for 4.2 seconds. Its instantaneous speed at the end of this 4.2 seconds will be, well, Vf equals Vi plus Gt. Its Vi is 0, so it's gravity times time. 4.2 times 10 is 42 meters per second. Okay. A rock falls for 3 seconds off a bridge. How far will it? So distance equals VIT plus 1/2 GT squared. This is 0 since it fell. So I'm going to have 1/2 GT squared. So 1/2 10 times 3 squared. 3 squared is 9. 9 times 10 is 90. Half of 90 is 45. A car traveling 25 meters per second, that's its initial velocity, comes to a stop, that's its final velocity, equal to 0. In 4 seconds, that's its time. What is the magnitude of its acceleration? Acceleration equals Vf minus V initial divided by time. Vf is 0 minus its initial velocity of 25 divided by 4. And if I do that out, I get 6.3 meters per second. It actually comes out to be negative 6.3, but because it asks for the magnitude, I'm just looking for the number. Here, that negative sign is telling me the direction, that it was opposite the direction of travel. A tennis ball is thrown in the air at 50 meters per second. That's its initial velocity. How long will the ball be in the air for? So for this one, it's going up and it's coming down. So it's going to go up 50 meters per second. So actually, I switched this. So I'm going to say my Vf equals my Vi plus Gt. It's thrown up at 50 here, and here it's traveling at 0. Okay, so my Vf is going to be 0 here. My Vi is going to be 50 here. My G is 10, and I'm looking for time. Okay, so I have 0 equals 50 plus 10 times t. And so when I work this out, I'm going to have negative 50 equals 10t, and then I'm going to end up with a time of negative 5 seconds. In reality, gravity is negative, and so that would have gotten rid of this right here. And so I have 5 seconds to go up, 5 seconds to come down. That's a total of 10 seconds. Okay. A car accelerates from 5.3, that's its initial velocity, to 43.1, that's its final velocity, in a time of 8 seconds. What is the magnitude of the acceleration? Acceleration equals Vf minus Vi divided by t. Again, it asks for magnitude, so I don't care about negative signs if there were any. But as I plug this in, I'm going to have 43.1 minus 5.3 divided by 8. And if I do that out, I'm going to get 4.73. So right here, 4.7 meters per second per second. If a car is driving down the road and slams on the brakes, which of the following is true? The car accelerates in the negative direction. That's true. The force of the brakes are applied in the opposite direction. So that's true. The car changes its velocity. Yeah, its speed is going to change. The car slows down. Yep, that's also true. So it is all of the above. In a kinematics problem, it is stated that an object starts from rest. If it starts from rest, that means its initial velocity is 0. So the car starts with 0 velocity. Initial velocity is 0. For this one, how much time does a car with an acceleration of 5 meters per second squared take to go from 5 meters per second, that's its initial velocity, to 40 meters per second, that's its final velocity. Acceleration of, that's my acceleration. How much time? I'm looking for t. So I need those 4 letters in my my formula, and the only one that has those 4 letters is right here. In the absence of air resistance, objects fall at a constant acceleration. They fall at g, which is 10 meters per second squared. A ball is thrown straight up at the top of its path. Its instantaneous speed is, when it gets up here, v equals 0. It goes up, stops, comes back down. An iguana runs back and forth along the ground. The horizontal position of the iguana in meters over time is shown below. What is the displacement? Displacement is a straight line distance. The difference between your starting point and your ending point. If you start at -2, and this is after 6 seconds, it ends right there. It went from -2 to 0. So it would be 2 meters. Okay, so it started here, it ended there. That's the distance, or the displacement. Now the distance would be a much larger number. What is the difference between a scalar and a vector? Scalars are magnitude only, vectors are magnitude and direction. Vectors include direction and scalars do not. All right, where am I at? All right. A student throws a ball into the air. The ball reaches its highest point and then falls back down toward the student. Which acceleration versus time graph? So again, kind of pay attention to what it is asking for. Acceleration versus time. No matter where an object is in the air, it's always under the influence of gravity, and gravity is, and in reality, it is -10 meters per second squared. We always just look at the magnitude and don't worry about the negative sign. But if I look over here, this would be the option. It is a constant negative. It is pulling it down. A cannonball is fired upwards and to the right of the cliff. Which graph best describes the cannonball's vertical velocity? So if I shoot something in the air, it's when it first leaves my hand, it's going fast, and then it goes to a 0, and then it accelerates down into a negative direction. So in this one, it's going fast, 0, and then negative. This one is the correct option. Okay, so if I throw an object up, it leaves my hand with its greatest velocity in the positive direction. It stops, goes to 0, and then it accelerates back down and has its fastest negative velocity when it lands back in my hand. A butterfly is flying around and its velocity is a function of time. What's the butterfly's displacement? Again, displacement is straight line difference in where it started and where it ended. It started at -2, it ended at 4. So it went 2 and then 4 more, so it went 6 meters. Okay. Here. All right. For this one, let me catch up on my cheat sheet here. Okay. A freely falling object is in the atmosphere or something that's so under gravity, things accelerate at 10 meters per second per second. So every second it will go 10 meters per second faster. That is right here. I can't read that. So if an object has a negative acceleration and moving in the positive direction, that means its velocity will decrease. It will be slowing down. I can't read which one that is. I think that's this one here. That says slowing down. Which graph? All right, so this one is a tough one. So again, this is a position versus time graph. How far away it is increasing in the positive direction. It stops right here. So if I were talking about its velocity, it's got a high velocity here. That velocity decreases to 0 there, and then the velocity increases as it comes down in the negative direction. So the one that shows that is right here, B. Has the greatest velocity here, and then it goes to 0, and then it increases on the way down. Which paragraphs below represent the same motion? So for this one, and I can't read these things, let me look at mine. So speed versus time is on the right, and position versus time on the left. So looking at these, the one that is correct is this one right here. It starts at 0 velocity, so position doesn't change very much. As it goes faster and faster, position increases, it separates out more and more. And again, I can't read that on there. Which statement describes the position versus time graph above? So position versus time. So here is 0, so something is going backwards, and it's going backwards at a constant rate. And so this says a car backs away slowly at a constant velocity. That is the correct one. If a car accelerates uniformly from rest is my VI, to, that says 50, that is my VF, over a distance of, I can't read that, but that's distance. What is the magnitude of the acceleration? That is A. So if I were answering this one, it's asking, use the formula, so I'm going to do VF squared equals VI squared plus 2AD. I'm going to rewrite this so that I'm solving for A, so I first need to subtract this out. I'm just going to write this here. A equals VF squared minus VI squared. And then to get rid of the 2 and the D, I had to divide. So I'm going to have that there. My VF squared, again, is 50. So I'm going to have 50 squared minus 0 divided by 2 times the distance, which is 180. So 2,500 divided by 360. And if I do that out, I get 6.9 meters per second per second. Oops. Coming to this one, it's just asking for which formula to use. Oh, so on your quiz, I flipped these back so you can see which formula I used here. I actually switched these on the quiz because it made sense to have this first and then this one. So the answer is this one right here. VF squared equals VI squared plus 2AD. An object is dropped from a building and falls for 6 seconds. You are given the following information. Well, if it's dropped, you're given 2 things. You're given that the VI equals 0, and you're given that G equals 10. And the 6 seconds here is my time. So you're given time, initial velocity, and the acceleration of gravity, which I can't even read those on there. I think that bottom one is what it says. Time, initial speed, and acceleration. Time, okay, that's this one. Time, initial speed, and acceleration. Good. An object dropped from a building, and I can't read that. Where is that one? An object is dropped from the building and falls for six. I just redid the same question again, sorry. So on this one, the car in the image is traveling 60 meters per second. That is VI. It can't read that. Suddenly sees a deer running the road. The deer is 240 meters away. That's my distance. Your acceleration right there, acceleration equals negative 4.5 meters per second per second. The other important thing on here, so the distance is 240 meters. It's asking if you're going to be able to stop before hitting the deer. And the key is there, are you going to be able to stop? And so your VF needs to be 0 if you're going to stop. So we're going to use these three here, and then we are going to use our formula that VF squared equals VI squared plus 2AD. And then we are looking to solve for D. Okay, so we're going to have, we're going to subtract out, we're going to have VF squared minus VI squared equals 2AD. And then I can rewrite this so that I have D equals VF squared minus VI squared divided by 2A. My VF is 0. My VI is, I think that says 60. So I'm going to have 60 squared divided by 2 times 4.5. And when I do this out, I am going to come up with 400 meters. And that is too far. Unfortunately, the deer is not going to make it. On this one, it is the Winter Olympics, and you're trying to figure out the acceleration. So I cannot read that on there. In the Winter Olympics, the skeleton is one of the fastest events. Sleds can reach speeds of 40 meters per second. If at time it takes the sledder to reach 40 meters per second from the starting line is 12 seconds, what is the average acceleration? So the 40 meters per second would be your VF. From the starting line, 0 would be your VI. The time is 12 seconds, and it's looking for acceleration. So for this one, I am going to say my acceleration is equal to my VF minus my VI divided by my time. 40 minus 0 divided by the time of 12. And if you do that out, you get 3.3 meters per second per second. Here we've got a skier going down. The skier is traveling at 3 meters per second. Then they see their friend ahead. They want to pass. The skier gets in a tuck to accelerate. Accelerates at, I can't see, oh, there it is. Accelerates at 2.1 meters per second squared, and does so for 4 seconds. Can't see that on there. T equals 4 seconds. And then so you're trying to find his final velocity. How fast was he going? So on this one, we're going to say VF equals VI plus AT. His VF is equal to his initial velocity, which was 3 plus his acceleration of 2.1 times the time of 4 seconds. 4 times 2.1 is going to give 8.4 plus 3 is going to give 11.4, which is that one right there. For this one, what is the approximate hang time up and down of a person? So for this one, you have to recognize that she goes up and down, okay? And you're looking for the total time up and down. How long did it take? So for this one, we're going to use our formula T equals the square root of 2D divided by G. Now, when we do our distance, she went up 0.9 meters. She also went down 0.9 meters. So when we do this formula, we're going to do the square root of 2 times 1.8 divided by 10. And when you do that out, you're going to come up with 0.42 seconds right there. And then for the last one, number 37, a projectile is fired straight up at a speed of 30 meters per second. The total time in the air. So the way I would approach this one is that it goes up to here. It started here. And so this right here, its velocity is equal to 0. Here, its velocity equals 30. And so I would say VF equals VI plus GT. And then I'm looking for my time, so I would say subtract out VI. So VF minus VI is equal to GT. I'm solving for T, so I'm going to have T equals VF minus VI divided by G equals, well, if I call this my initial, and I'm going to do it like this, this is my initial velocity, this is my final velocity, then I'm going to have my final velocity is 0. So 0 minus its initial velocity of 30 divided by G, which is 10. But remember that in reality, G is negative 10. So I'm going to have negative 30 divided by negative 10. 30 divided by 10 is going to be equal to 3 seconds. That 3 seconds is it. Whoa, what did happen there? That 3 seconds is it going up, but recall that it also is going to take 3 seconds to come down, so the total time will be 6 seconds. Okay. I realize I went through that really quickly, but people miss different questions. You should focus on the ones that were confusing to you, and hopefully this helps. If you didn't do well on the test, I hope you do well tomorrow.